Hello, dear student. Today we start a new subject, and our first lecture is history and essence of scientific knowledge. Uh, I'm Professor Roman Moskalenko, and we start from some general information about science and our um, subject. It's science is very important in human history and development in um, thousands of years of history, uh, supported by some development of technology and science. And science make our modern society it's as is. We have a lot of devices, this social structure, hierarchy, and this fantastic machines. It's many of all uh, material uh, heritage from previous generation. It's result of scientific research in developments of human society. According to Aristotle, science is form of knowledge for sake of knowledge itself. This obtaining this knowledge is highest goal of human activity. Uh, Medieval scientist and alchemist Francis Bacon it's have more short definition is science is historical product of human activity. Nowadays it's some average definition is we can it's like science is special sphere of human activity aimed at obtaining new knowledge information about nature society thinking and the laws and their development. Uh, the main reasons for emergence of science this is it's very simple. It's obtaining food, house, health, and war. Of course, it's probably war is one from main drivers of scientific research. It's we can see it's nowadays on this situation which we have. Um, Also, another reason it's some developments of indeed personal developments and individuals. It's like some philosophy. It's need for knowledge, search answers on many questions from nature or society, etc. So today we have several classification. It's some discussion like question about uh, definite some periods or etc. But it's one point of view. It's humankind starts from personal and worldview orientation of science. It's from some ancient time to Galileo and Newton. In a new age, it's technological, material, and production orientation of science. Some industrial revolution, 17th century to present day. And some more philosophically definition, it's self-existent orientation of science, which I'm at the development of intellectual creativity potential, personal, individual. Usually, scientific knowledge leaves some typical uh, this life. It's example of some narrow fields of science. An example, somebody invent something or investigate some new materials. An example is it's probably graphenes. It's first it's some on first stage it's idea and many people interested in new material and starting search and investigate and make many experiments. It leads to explosive growth of information about it material. Next stage is exploitation of idea. Lots of publication. It's very high pace of this scientific investigation, and later interesting to this field it decreases. It's also it's in to 20 years ago, 15 years ago, it was graphenes, and many people think it's like elixir. It's used for antibacterial therapy, anti-oxidation, and some superconductivity, etc. Now we talk. It's another material. Many people. An example is many people investigate vaccines. It's some carbides of metals, titans. Also, increase of many publication and a very high pace of scientific research. But in the last stage of saturation, it is when this most of people looks at this new material or new knowledge is not elixir, not answered for all question, and have some narrow exploitation application, and it leads to exhausting this interest in this idea in materials transferred to textbooks in its later this new branch disintegrate for narrow subgenres of this science. It's typical example of development of something. It's in pathology. I can bring example from pathology. It probably less than 10 years. It's idea of liquid biopsy. It's many people thinking it's something new tool for in oncology. It's answer for many questions. It's personalized medicine, etc. But in last year, it's too many some doubts in this idea because it's technically it's difficult to prepare good samples for this very high technology investigation, and it leads many people understand it's not answer, not it's probably in some narrow field it's possible to exploit and apply, but for routine practice it's not case for routine practice. Next, it's next question. It's scientific revolution progress. It's two type of development of scientific knowledge. It's rapid break and gradual movement. Okay. Scientific revolution is radical break of system of scientific concepts, theories, principles, and laws. In this something grandiose, big in investigation, some invention leads to total changes in many scientific branch. And this example is nuclear power or computers or something, or a steam machine. It's something very meaningful and big, uh, which this change lead to revolution in science and technology and society probably. Okay, another type, it's a slow movement. It's technical progress. It's slow, gradual movement, science and technology, evolutionary development of all elements and productive forces. And it leads to change in society structure. This is uh, something uh, like it's the development textile production in new age in or introduction of some new material, new branch of science, and um, it's a more it's this evidence more visible from historical perspective. In it's also some personal point of view, some scientists, but it's uh, on this example we can understand what about revolution. Uh, First revolution was Indo-European technological revolution. It was 2 or 1,000 before Christ. It's invention of wheel and usage of horse. This is uh, this is history happens between North Hindustan and Ukrainian steppe. It's Caucasian or Persian. This uh, uh, this it was very very potent revolution because this usage of this wheel in horses in war practice it was like nuclear power in for these years because it's people who use Indo-Aryan people who use these advantages resolve very in some uh, advantage in wars, and it leads to many like genocide for people who can use this technology. It's this information keeps in some mythology. It's like it's about Indra or something like that. It's from this. It was very important for human history. A very important was Greek technological revolution. We know now about Greek culture. This Greek and Celtic culture. It's some bronze usage of bronze, and this many technologies was invented in this era. It's also in all time. It's applying to war. And the next technological revolution is Iron Age. It's German Slavic revolution. Usage of iron in war campaign. It's it's also linked with movement of these tribes. This this revolution is lead to this Roman Empire was destroyed by barbarian, which used some iron weapons and etc. It leads to change ethnic composition of many countries and continents. And next revolution, it's medieval technological revolution. It's epoch of crusades, and it's some feudal structure and also tied with some weapons and helmets, etc., and shields. It's some uh, devices for the Ziege, and also this some production of um, some like for agriculture instruments. It's also was important changes in history. And the last, from history perspective, revolution was in Renaissance. It's powder. It's choose for medieval weapons to these guns and rifles. When this secret of this weapon transferred from China to Europe, this period it's like New Age. Uh, as we can see, it's historical scientific revolution. It's tied with war. But the next classification, it's use nowadays in philosophy of science, etc. It is a universal technological revolution. It's another point of view. This revolution present from New Age. It's this revolution starts from Netherlands and Lombardia from North Italy. This is the invention of bank system, this financial revolution, and some changes in agriculture. And next, it's agriculture became more effective. Next revolution is first industrial revolution in steam machine. It's this textile in England, in Great Britain, is invention of a lot of machine mechanization of this work. And after Franco-Prussian War, to the end of First World War, it was Second Industrial Revolution, create of some trusts or some monopoly in oil, steel, gas, etc. It's creation. This revolution created this world which we can see. After Second World War, it was in time of Cold War. It's development of nuclear technology create this revolution based of some uh, atomic force, and in last quarter of 20th century, it was information revolution, telecommunication, and computers. It this this revolution, it's classified like systems, and it's um, uh, innovation based on two last revolution. It's information revolution and biotechnological revolution. Mm, for example, I take this 2001 when was deciphering of genome, and nowadays we receive a lot of news about some chips for in brain from Musk company, or bionic prosthesis, etc. It's this future became nowadays. It's this we can trace these changes in like online because it's last year. I think it's now it's underestimate this artificial intelligence probably is a continuation on information and telecommunication revolution, but uh, I think it's probably it's something another. It's probably we live in time new revolution when this artificial intelligence we can create uh, large massive information. It's and this I think in nearest future many profession was outdated in artificial intelligence push out humans from some fields of technology, industry, science, etc. Okay, it's nowadays. Difference between technical revolution and the technological change is not clearly defined. This is technological change is some introduction of new technology, but we need some time period for distinguish this innovation, its revolution or some change. In an example is this nowadays with artificial intelligence. It's all this technological change um, increase productivity, efficiency in this leads to improve human life in like idea. Not always, but this invention and some technological break lead to have impact on business, education, social interaction, finance, and of course research. This it's very difficult to predict changes. I mean, it's an example is like usage of these drones in at the war. It was like some very rapid change in we can see it's all innovation on battlefield very quickly spread. An example in last month, an example our workforce use drone with some fire system. In 2 weeks, Russians copy this technology and use, or vice versa. Russians use large kamikaze drones for hitting our some facilities and energo objects infrastructure, but by some reverse engineering, Ukrainian people create similar drones and now hit these oil depots and some arsenals. This is depends of context, historical context, and this technology. Its first applied drone was in 22 in June, but for after 2 years, it's very huge history of this development. It's some technological innovation happens every month probably. This is this is another example of why it's war. It's some driver of some innovation. It's very pity, but it's fact. Okay. Um, how it works and this technology, how it provides these technological changes. It's um, invention. Is this creation something new? Probably it's breaking through groundbreaking technology. Which can start or not start some change or revolution. And this system of patents, its main idea, this system is keeping of author authorities and its priority, and some inventors receive some money, but it's this system is some not allow very quick for development of technology because it's need a lot of time for create patents because it's need several years for the process of patent filling patent application. It's in Ukraine, an example, it's more than 2 years. It's very it's some patent of some technology improvement. It's needs until 1 year, 18 months. It's this time I think it's wasted. It's people work with papers, not with some technology. Okay, next stage it's after invention is diffusion. This technology spread. If this technology useful, it's this. If society if very needs this needs, it's very quickly this technology spread in industry. If technology not work properly, it's like this leads to stop development, this usage, this invention, etc. But if industry economy needs this technology, it leads to a high level implementation of this technology. Of course, after that, in society uses this invention in culture, in politics, in market, etc. It's very quick in this our digital epoch. It's very easy in globalization, very quick spread on all continents. Okay, next chapter. It's about main concepts of scientific research. Is first it's idea something. It's idea is intuitive explanation of phenomena without intermediate argumentation, without awareness of the entire set of connection on the basis which conclusion is drawn. Idea based on knowledge, but um, reveals previously undiscovered regularities. Okay, we have idea, but we don't know how it works. It's some intuition. Probably it works, but somebody don't know how it works. But it should work. It's idea. Next, it is hypothesis, scientific hypothesis. It's a form of scientific knowledge with help of which one possible options of solving problem was formed, the truth of which has not yet been clarified or proven. This hypothesis helps unravel some causes of something affects phenomena. And the next hypothesis more real because it's which should test this hypothesis. It's proof it's true or false. Is in result of this test is the hypothesis can be replaced by another or turned into law or theory. On this picture is this hypothesis of formation of solar system. Sun in center of this disk and formation planet from dust. It's hypothesis Kepler. It's science divide on some categories. It's fundamental science, some theoretical fundamental science. It is science is learning the objective laws of development of nature, society, and this science not have some goal to have final results or have some practical application or this science not make some goal for be useful. Some theory, it's ideas, etc. It's some fundament for next stage. It's applied science. Applied science use for apply results of fundamental research to solve specific practical problems. It's not directly use directly technology. This goal of next type of next category of sciences, applied developments. It's this science directed to practical results in the implementation in form of technological process, new designs, materials, or if it's art and humanities science, it's some laws, regulation, programs, or standards. This managemental decisions. It's we can look on this scheme. It's fundamental science, basis for applied science. Applied science helps applied developments. It's all scientific research have some purpose um, for some planet results. It's some probably it depends of category of science. It's some useful product or theory or achieving some quality indicators, etc. These all purpose goals connected with conclusions of scientific works. If you set some goal, you should this reflect this goal in conclusions of your scientific work. It can be thesis, article, or PhD, dissertation, etc. Uh, for achieving goals and purpose of research, useful always set some specific task. All tasks correspond section in graph of results of research. And it's estimated of 3, 8, etc. It depends of scientific research. Next, it's in this lecture I add this information. This probably it's quite enough for students, but it's in scientific research we have object and subject of research. Usually we use it grant applications. This information it's dissertations or some projects in subject related to object to subject, general and partial. It's object it's something big and subject inside of this object. An example, now we work on a project for development of diagnostic program in digital pathology, and object is diagnostic process, but subject is development of digital program or digital algorithm for diagnostics. Okay. We understand the subject contained object inside, and the subject determines topic of scientific research. It's from subject, not from object. It's very important in nowadays. It's run some interdisciplinary or multidisciplinary research. It's very difficult find some novelty in narrow field. If somebody discover new material, it's in a stage of saturation of this branch of science. It's very difficult find novelty, and and scientists use interdisciplinary or multidisciplinary approach to scientific research. I can give my example. I start second PhD, second doctoral level, and I think about topic of my scientific research, because it's very difficult in small city find lots of something modern technology and something very advanced. But I think about some interdisciplinary research with physics, pathology, and physics, and I my goal was it's classificates in different pathology. I use method of traditional pathology and also use physics material science methods for characterization of these pathological calcificates in different tissues. It's give me novelty and this inter and multidisciplinary approach. Also, it's exists some transdisciplinary approach. It's from different sciences like psychology and pathology. This science branch of science is very far from each other. Okay, thank you so much. Today it's all.